Hello everyone, this is our next video of IPSec series. In today's videos, we are going to discuss packets and integrity protection process, and also we will learn packets in a detailed way. So let's start with the integrity protection process. So what is the integrity protection process? The first step of integrity protection is to create a hash by using a keyed hash algorithms, also known as message authentication code MAC algorithms. So the integrity process we called as it's a process where using a code they will generate a output of it, and it is mentioned here using a keyed hash algorithm. So this is the keyed hash algorithm, also known as a MAC, message authentication code algorithms. So this is an algorithm to check the integrity process. So now a standard hash algorithm generate a hash based on the message, while a keyed hash algorithm creates a hash based on the message and a secret key shared by endpoints. So let's understand the meaning of this. So let's go to my whiteboard. So what is the meaning of the keyed hash algorithm? So key hash algorithms. So let's say this is the two VPN gateway. So this is the, let's say, site 1, and here we have a site 2. Site 2. So what is the message authentication code? So basically this is the algorithms where they will generate a hash of the data. So this is the two types. So first first is the key this is the key type key hash, and second one is the, let's go to back my slide. So we have a two types of algorithm. One is the keyed hash algorithm, second is the standard hash. So what is the difference between the keyed hash and standard hash? So in the keyed hash, let's say this is the data, and this packet you can consider as a data, and plus we have a secret key. So we called as a share secret key. I am trying to make a key kind of thing. Consider this is the key. So data plus key, the combining, we get some output, and that we get the hash value, and that's hash value, this is the hash value. So in the process of key hash, the data will process with the key, and after that we get the hash value. And in the normal standard hashing, what is the meaning of the standard hashing? Let's remove this. So that is the reason in the VPN gateway both side is having keys. So using the key and plus data they generate a hash value. So what is the standard hashing? So in the standard hashing, this is the data only. This is considered as a data. So after the data, we'll get the hash out. This is the hash. So in the standard, let's remove this also. So in the standard hashing, data is hashed but don't have any kind of keys involved. This is the standard. So in the standard hashing, this is the data value, and in the data value we get the hash, but in this case we are not using any kind of key to perform these hashing algorithms. Now let's back to this slide. So we discussed this. A standard hash algorithm generate a hash based on the message. So message means the data, while a keyed hash algorithms create a hash based on the message and secret key shared by two endpoints. So after message plus secret keys, based on that they will perform the hashing. So this is the two types, standard and key. So let's move to the another point, integrity protection process. Let's move it. The hash is added to the packet and the packet is sent to the recipient. The recipient can regenerate the hash using a shared key and confirm the two hashes are match. So in this case, again go to the whiteboard. So this data is generated now. So what will happen? So in the keyed hash, it is like a, so in the keyed hash, this is the key, this is the, you can consider as a message or data or packet plus key. They will generate a hash. Now this hash will forwarded to the next host or recipient. Then hash the recipient, here I would say recipient, and the recipient will also perform the hashing using this key which is shared on the both side. So for key plus message, they will get the hash value. In the based on this hash, they will say that this is the legitimate hashing or it's a not non-legitimate hashing. So this is the recipient and this is the sender. So this is the sender. So sender, what sender is doing? Sender is doing message plus key will get the hashing. This hash will send to the recipient. This is the recipient. Recipient is having already key. So using a key, they will have also message. After the message, they will generate a hash. On the hash, will get to match that this is the, based on this output hash will match the will match the authentication of the sender also. So now let's move to the another point. So which provides the integrity protection of the packet. So on the both side is having the shared secret key. Now they will perform the algorithms like integrity protection algorithms. They will get both sides, they having their output and they can match their, they can authenticate the packets. So which provides the protection for the packets. IPSec uses hash message authentication code. So this is the HMAC. So in the general, many times you people have seen that this term. So hash message authentication code HMAC algorithms which perform two keyed hashes. Example HMAC MD5, HMAC SHA. A common MAC algorithm is AES cipher blockchaining MAC. So in this case, AES included XCBC and MAC. So basically these are the algorithms mechanism so to perform the hashing. So whenever any interviewer asks what is the AES, so A is the hashing mechanism or this is the MAC which is message authentication code. So this is the algorithm to perform the hashing. Both sides is having shared secret key. So now they will hash the data, how to perform the authentication using these algorithms HMAC, MD5, HMAC SHA or AES cipher blockchaining. So this is the understanding of the integrity process. And now we'll move on to the AH header. So this field contains IP protocol number for the next packet payload in the tunnel mode. The packet is the IP packet. So next header value is set to 4 in IP to IP. In transport mode, payload is usually transport layer protocol, often TCP TCP IP protocol number 6 and UDP IP protocol number 17. So this is the AH header which I can show here. So in the case of tunnel mode, we can see that next I is equal to IP field is added. And in case of transport mode, it is not added. So it point I have explained already in the previous video that how this is added on the next is equal to IP. So in the AH packet, this next is equal to IP is added. So after that, this address will fill. So AH header, first we have new IP header, and new IP header is this header next is equal to IP. So which contain the TCP or UDP. So it is mentioned here. So in the next header value is set to 4. In the transport mode, it is the TCP UDP. So in case of tunnel mode, it is set to the 4 which I just show you. So payload length reserve. So this value is reserved for future use, so it should be set to the 0. This is the payload length of the AH packet. And now this is the SPI security parameter index. Each endpoint of each IPsec connection has an arbitrary chosen SPI value. So basically the SPI value is a custom tag. So both peers, like both, let's say this IPsec, these are the IPsec connections running on the internet. So they have negotiated, let's say we have some algorithms running. So let's say AES and 256, and here we are running some algorithm. Here we will also run the same algorithms, AES, SHA-256, MD5, group 15, and so on and so forth. So based on the two hashing, they will assign a custom tag of this IPsec connection. Those custom tag we called as a SPI value. So they will generate this SPI value after the negotiation of security parameters which is defined in the IPsec connections. So has an chosen SPI value which act as a unique identifier for each connection. So each IPsec connection is having their unique SPI value, and we called as unique, or we can say as a custom tag. Both will be fine. The recipient uses the SPI value along with the destination IP address optionally. The IPsec type in this case, we are in the AH. To determine the security association is being used. So both to perform the SPI, they are having the security association, and the security association means that handshake. Both side they have some security parameters like AES groups, or we called as a haggle. So in the IPsec we have to define the algorithms. Those session to determine which security association is used, this SPI is running. This tells the recipient which IPsec protocol algorithm is applied. So again, same the point. This is used to tell the recipients IPsec protocols and algorithms have applied to the packet. So using this SPI, that both connection will able to identify the which algorithms is applied. So it is a similar kind of haggle. Haggle is it is the short form of the IPsec tunnels. So we have defined in the IPsec connections in the same to perform the IPsec connections, we have to define the IPSec algorithms like a SHA-256, AES. So based on that, this SPI value is formed, and this is the custom tag for the each IPSec connection. And sequence number, it's also added to the AH packet. So each packet is assigned the sequential number, and only packets within the slide window of sequence number are accepted. This provides against reply attacks because the duplicate packets will be used the same sequence number, and this also helps to denial of service attacks. So basically, sequence number means that, let's say this is the packet 1 and this is the packet 2. So in all the H packets, they are assigning the sequence number to identify it. Let's say if any new packet will come and doesn't match the sequence number, they will drop it immediately to perform the, we can say that to maintain the integrity, to increase the security, this field is added to the AH header. So whatever we discuss, this is the one picture. So in this field, in this we have discussed the next header. So in the next header, in the case of the tunnel mode, it is next header equal to TCP IP, where the new IP header will be added. In case of tunnel mode, no new IP header will be, and no new IP header will be added. Only that they will say that next is equal to IP, or next is equal to IP in the case of tunnel, TCP UDP in case of transport. Payload length, it is payload length and reserve, security parameter index, and sequence number. So authentication information, it is, this field contains the MAC output described as per integrity process. So both sides will have negotiated using their algorithms, and whatever hashing they will get, that will this field here is to display that whatever will get to perform on the after the authentication will get here. So this is also a tunnel mode packet. So AH length reserve is always 0. SPI, both side is having the unique identification to perform, and also this is unique for each IPsec connection. Sequence number is they are assigning the sequence number to maintain the integrity, and authentication has data. So both IPsec VPN will negotiate and they will create the hash, and this is the head. This is the authentication data of the AH. So let's discuss, let's see if anything we missed today. So integrity we covered it, and AH header we covered, payload length it is covered, so SPI we also covered. So yeah, so we covered on this video. So this video is related to the AH packets. So I hope you enjoyed this video, and if you enjoyed, please hit the like button and subscribe the Firewall Experts to stay connected for the new video. Thanks for watching Firewall Experts.